So there is a scenario here which is given. So do not get confused by this. This looks very complicated. Yes, but look at the information that is given. Okay. So first write down the given information, which is you have a capacitance which is 3 into 10 raised to minus 14 farads. And then you have a 0.5 volt connected across the capacitor, and it's asking you to find out the number of electrons. So I have written here the capacitance is 3 into 10 raised to minus 14, the voltage, and then I need to find the charge. So obviously I would use Q is equal to C times V, this formula, and then find out the charge, which is 1.5 into 10 raised to minus 14. Now it's asking you to determine the number of electrons that must move on the capacitor to charge it. So how do you find the number of electrons? So the formula is, again, it's easy. Electrons is equal to total charge divided by divided by charge per electron. Okay. So the total charge is the one that you found out here, divided by charge per electron. So now this one is a constant value. So do not worry if it's been asked in the exam, they will give you the value for charge per electron. It's a constant value. And then you just directly divide it and you get 93,750 electrons. Now let's move on to the next one, which is the question number 7. So here you can see capacitor 1 is given and capacitor 2 is given, and you need to find the total capacitance for C1 and C2 connected in series and in parallel. So before that, let's look into the PowerPoint from LG Create. So here you can see how the capacitors are connected in parallel. Okay. And this is how you draw the schematics of capacitors connected in parallel. So it is just the opposite of resistors connected in a parallel circuit. So normally for resistors connected in a parallel circuit, we saw that, Yes. So we saw that when resistors are connected in parallel, we saw that the formula was 1 divided by R total is equal to 1 divided by R1 plus 1 divided by R2 if there were two resistors. But in this one, in parallel, it's just going to be the opposite capacitance. Total capacitance is going to be capacitance 1 plus capacitance 2, which means in parallel, the effective capacitance is going to be the same. So the total capacitance of the whole circuit is going to be equal to the sum of individual capacitance in the circuit. Now moving on to the next one. This is capacitors connected in series format. So you can see one leg of the capacitor is connected to the other leg of the capacitor through a wire. Okay. And this is how a series connection is in a schematics. Now again, it's just the opposite of resistors in series. So in resistors in series, we saw that when resistors were connected in a series fashion, then you saw that R total is equal to just R1 plus R2 plus R3. But now it's just going to be the opposite. So it's going to be it's just going to be yes. So now the capacitance, for finding the total capacitance, how do you do? It's just the opposite of resistors formula. So it's going to be 1 divided by total capacitance is equal to 1 divided by C1 plus 1 divided by C2, and then definitely have a third capacitor. So it's going to be 1 divided by C3. So remember, it's just the opposite of resistors in parallel and series connection. Okay. So here you can see there is nothing to be confused in this. It just says that you have, for example, if you had 3 capacitors connected, okay, in series format. So first one, second one. Yes, this is just 2 capacitors. So this is C1 and this one is C2. So how do I find the total effective capacitance? So I'm just going to write 1 by C total is equal to 1 by C1 plus 1 by C2. Now when I solve this, I'm going to get 1 divided by CT is equal to, so again you need to make the denominator same. So C2 times 1 is going to be C2 plus C1 times 1 is going to be C1 divided by C1 times C2 is going to be C1 times C2. Now remember, this is the answer for 1 by CT, 1 by total capacitance. Now I want to find total capacitance. So I'm just going to inverse this answer, which is, I'm just going to inverse this answer. So it's going to be C1 times C2 divided by C1 plus C2. So this is how you got this formula. Okay. So there is nothing to be confused. You can just directly write it as 1 by C total is equal to 1 by C1 plus 1 by C2 if you have 2 capacitors. Now looking into this one, you can see that in a parallel fashion, the capacitors, the total value of capacitance is always increased. Okay, so capacitors in series reduces the total value of capacitors because definitely it's 1 divided by C1 plus 1 divided by C2, whereas in this one it's just you're adding up the capacitors. So in series, remember, because of this formula, it's just the opposite of resistors. You can see that the total capacitance of the capacitors is always going to be less than the smallest value. So moving on to this one, if you see, let's solve this and see. Here's just one example. So we can move on to the practice problems. So you have 3 1 microfarad capacitor. So each one is 1 microfarad. So you have C1. Again, I always say write your given information. C1, C2 and C3, which is 1 microfarad. And then it's told that it's connected in parallel. So always parallel is just the opposite of resistance. So C total is going to be equal to C1 plus C2 plus C3. And you get your total answer after adding it, which is going to be 3 microfarad. Now moving on to the series one. We can see that we just need to use the opposite formula, which is going to be 1 divided by C total is equal to 1 divided by C1 plus 1 divided by C2 plus 1 divided by C3. Again, I always say that please write down your given information, your formula that you're going to be using, steps, every step's clear one by one. That's a good habit of solving problems because that reduces errors. So please make that as a good habit of solving problems. Yeah, and so once you do this, apply the values and then you should get your answer. So here you get 0.3 microfarads. Okay. So let's move on to the practice problems and we can start doing this. So the 7th one, Again, first you need to write down the given information. So the given information is so here you can see capacitance 1, which is 10 farads, and then you have capacitance 2, which is 5 farads, and then it's asking you to calculate the total capacitance of C1 and C2 connected in series and parallel. So let's draw the diagram. So when it's connected in series, so write the topic series, and then see it's connected in series. So remember, capacitance of same length, okay? So this one is C1 and this one is C2. Now what is the formula to calculate capacitance in series? One divided by C total is equal to 1 divided by C1 plus 1 divided by C2. So your answer is going to be so just apply the value, which is 10 and 5. So it's going to be 1 divided by 10 plus 1 divided by 5. Now don't forget that it's written as farads. So it's in its standard format. So you don't need to convert anything. So it will stay as it is. And once you do this, you will get your 1 divided by CT as so it's going to be CT is going to be the inverse of this answer. So it's going to be 50 divided by 15, which is 3.33 farads. Now moving on to the 8th one, you can see that if two capacitors in question number 7 were connected to a 50 volt battery, determine the voltage across the capacitors for each connection types. So if two capacitors, so let's see, so for series connection, the charge of the capacitor is the same as the charge on the effective capacitance. So you know your C1 and C2 is 10 and 5. So this is the same as just Q is equal to C times V. Okay, so you know your total capacitance is 3.3 and then your charge is something that you need to find, and then your voltage is 50 volt battery. So you just directly put the value and then you get Q is equal